So guys, let's next discuss the spectrometer experiment that is given in the 2019 structured question, right? So they're saying a standard spectrometer, a glass prism and a monochromatic light source are used to determine the refractive index of the glass, right? So if you see, of course, like this is going to be the collimator, right? And this is the prism table, right? Prism table, and this is going to be the telescope, right? So, and this is going to be the source, light source. All right, so this is the prism. All right, this is the prism. Okay, so this is the simple structure of the spectrometer. Regarding this only they are going to ask the problems, so therefore, like, that is why I showed you a figure of how this is going to look like, in order just like, then of course you will straight away get an idea, right? So yes, let us see what it is. What they're saying is a few necessary adjustments are actually required. So a few necessary adjustments are to be done to the spectrometer before starting to take measurements. Before taking measurements, certain adjustments are supposed to be done. So what is the adjustment that should be done to the eyepiece, right? So first of all, if you see, right, so first of all, when you consider the adjustments, first of all you need to adjust the telescope, right? The first adjustment is you need to adjust the telescope. When adjusting the telescope also, you have to first of all adjust the eyepiece, right? First of all adjust the eyepiece, next the objective piece, right? Next the objective piece, and then thereafter we will have to adjust the collimator, right? And then thereafter, after adjusting the collimator, we have to adjust the prism table. So you need to remember the order as well, right? So first of all, the telescope, the collimator, and the prism table, right? So when we adjust the telescope, actually first of all what we adjust is the eyepiece, right? So what is the adjustment that should be done? So actually when you consider the eyepiece, actually when you see, of course this is how you are going to see, right? So you're gonna see two like, first of all, the eyepiece, when you see through the eyepiece, this is what you're going to see. Actually these are called the cross wires, right? Cross wires. Actually initially the cross wires are going to be somewhat distorted, right? Likewise something like this, right? So it's going to be somewhat not clear, right? It's not going to be clear initially. So what you need to do is, by looking through the eyepiece, right, you have to adjust the eyepiece, right? You have to adjust the eyepiece, like there's a ring around this, and you need to rotate it, and then you need to adjust it until you see a very clear figure as this. I mean, like, the crosswires needs to be seen clearly, right? The crosswires needs to be seen clearly, right? So therefore, actually what you need to do is you need to adjust the eyepiece until a sharp, clear image is seen. Clear sharp image of the eyepiece is seen, right? Image of the crosswires are seen, right? You need to adjust the eyepiece until you see a sharp image of the crosswires. That is the first adjustment that you need to do to the eyepiece. All right, so next, the second problem is telescope is pointed to a distant object and it is adjusted until a clear image of the object is formed on the crosswires. What is the purpose of this adjustment? Actually, guys, like, before you use the spectrometer, right, you have to, like, this telescope is movable, right? So, like, you will have to move this, and you need to look at a distant object, right? You need to look at a distant object, maybe a tree or something, right? So maybe a tree or something, right? So in this way, and you need to adjust the eyepiece, objective piece, right? This is the eyepiece here, right? So the eyepiece is adjusted, right? So eyepiece is adjusted initially. Next, you need to adjust the objective piece. Like initially, you are going to see the image in this way. Like it's going to also be somewhat distorted, right? Not very clear, right? Not very clear. So therefore, to see this the far away object very clearly, you need to adjust the objective piece. So what is the purpose of this? The purpose is you will see this far away object clearly only when parallel beams of light enters to your objective piece. If this is the objective piece, right? If there is a far away object, then of course there should be parallel beam of light that comes, right? There should be parallel beam of lights. You need to adjust the objective piece in order to receive parallel beam of lights, right? Parallel beam of light. Then only you can see it clearly, right? At this point, the image, right? The image of this object. So the adjustment actually is done. The objective piece is adjusted in order to receive parallel light rays by the objective piece, right? You need, so what is the purpose of adjusting the objective piece? That is in order to receive parallel light rays by the objective piece. That is the reason, right? Okay, you can write it on your own words if you understood what I explained, right? So that's not an issue. Okay, let us move on to the next thing. That is, what is the adjustment that should be done to the slit of the collimator? What should be the adjustment that should be done to the slit of the collimator? Actually, so when you consider the slit, it's going to be something like this, right? It's going to look something like this. So if you consider the slit, right, it's going to be in this way. All right. So it's going to look like this actually, right? So you need to somehow make the slit as narrow as possible, right? You need to make the slit as narrow as possible. If you consider this is the collimator, this is the point where the slit is, right? This is the place where the slit is. Somehow you need to narrow the slit, right? You need to narrow the slit, and also you should place it vertically. You need to make sure that it is vertical. The slit is vertical. Like you can also obtain a slit in this way, right? So that is also possible. You need to understand, right? This, sorry guys, like this, the slit can also be in this way. If you see, it can be inclined as well, right? So like therefore you need to somehow, this is the correct way, right? This is wrong. So therefore you need to, the first thing is you need to make it narrow, as well as you need to make it vertical, right? You need to make it vertical. So these are the two reasons, right? What is the adjustment? Slit must be made narrow as possible, right? Narrow as possible. All right. So the next thing is also it should also be maintained vertical. Maintained vertical. Okay. So that is also done. Next, let us see. The telescope is bought in line with the collimator, right? So the telescope is bought in line with the collimator. Then the collimator is adjusted until a sharp image of the slit is formed on the cross wires. What is the purpose of this adjustment? They are asking the purpose of this adjustment. So actually, so at a certain instance, right? So what we do is, so if this is the collimator, right, if this is the collimator, what we do is, and if this is the prism table, all right, so we actually directly look at the collimator, right? This is called the collimator adjustment. The collimator adjustment, we directly look through the telescope and see whether we actually receive, like, by adjusting, like actually we look through, we need to look through the telescope at the image of the slit, right? This is seen, why, to confirm that we receive, the purpose is to confirm that we receive parallel light from the collimator, right? So we look through the telescope, right? We look through the telescope and we adjust the collimator until we see the slit, image of the slit very clearly. So if it is seen very clearly, that means the collimator is adjusted such that it sends out a parallel light ray. A parallel light ray. We have already adjusted this to receive parallel light ray. So if we are clearly seeing the image of the slit, that means the collimator is also now able to send a parallel light ray, right? So in order to the purpose is, in order to send a parallel light rays by the collimator, in order to make sure that the collimator sends parallel light rays, right? So those are the questions regarding the adjustment, guys, right? So there's plenty of adjustments asked in few, like last if you consider the previous years as well, this spectrometer experiment was repeated plenty of times, right? So if you see in all the spectrometers, they were very focused on the adjustments, right? So you need to while you are covering the spectrometer part, please make sure to cover the adjustments part quite significantly, right? So give the priority for the adjustment parts somewhat significantly. All right, okay, so right, okay guys, so we are gonna discuss the B part, right? So they're saying, in order to level the prism table, the prism is placed as shown in the figure 1 and the screws P, Q and R are adjusted, right? So like, okay, so one thing that you need to note is, like, when you place the prism on the prism table, in order to level the prism table, you need to place it in a certain manner. One thing, the first thing is, like, you need to place the prism angle very closer to the center of the, this is something addition, right? So this is like, I'm not discussing the question. So like, one thing is, like, you need to place the prism very closer to the center of the prism table, all right? And then thereafter, once one prism surface should be perpendicular to the line joining two screws. And if you see, okay, Q and C is there, so the surface AB of the prism is perpendicular to QC, right? So these two conditions should satisfy. First thing is, you need to place the prism angle, you need to place the prism angle very closer to the center, and then one surface of the prism should be perpendicular to the line joining two screws. It can be either QC or PC or whatever. It's like, okay, fine. Now, then they are asking, when the telescope is at T1, when the telescope is at T1, the screw Q is adjusted to obtain a symmetric image. Okay, when the telescope is at T1, the screw Q, when the telescope is at T1 location, they have to adjust Q to obtain the image of the slit at the center. So when they look from the position T1, they will have to adjust Q1 to get the image of the slit to the center. That is what we're saying as leveling. Okay. So initially when the this is at T1, when the telescope it has T1 position, this is how they are going to observe. Initially they are going to see this. So when they adjust Q1 slightly, it's going to go towards the right, and then it's going to come exactly to the center, right? So now when you observe from T1, it's leveled. Next, what you need to do is, they're saying, when the telescope is moved to the position T2, when you move the telescope to the position T2, what screw do you need to adjust? It's quite simple, right? So if T1 is placed, this is what you need to adjust. If T2, Q is what you need to adjust, right? So you need to adjust P. You need to adjust P actually, right? So you need to shift it like when you shift the telescope to position T2, you will have to adjust the P screw, right? So actually in that case, from this side, from this corner, the slit will step by step come to the middle. Initially when you look from the position initially when you look from the position T2, right? T2, the slit would be somewhere here, and then it will be step by step, it will move. When you adjust the P screw step by step, it will come to the center, right? Step by step it will come to the center. All right, okay. So now that is adjusted. All right, fine. Then the next problem is, a student stated that the leveling of the prism table could be easily be done using a spirit level. So you know what a spirit levels, right? So like mostly when constructing houses and all, like if you know, when constructing walls and all, in order to check whether the wall is vertical and whether certain structures are horizontal and all, we use spirit levels, right? So actually it's a very useful thing. Then they are saying a student is using a spirit level. A student that stated that the leveling of the prism table could be easily done using a spirit level. Actually, what do you think? Actually, you can't use a spirit level, guys, right? You can't use a spirit level, because the thing is, if you can use a spirit level, like you do not have to undergo all these difficulties to level the prism, right? So actually you could easily place the prism, the spirit level on the prism table, and then level it easily. But actually what requires is, you need to understand well that, like, we need to level the prism table, not horizontally, right? If you see, like, okay, let us assume this is the side view of the prism table, right? Actually we do not have to level the prism table horizontally. Okay, this is the horizontal axis. That is not what's required. We need to level the prism table parallel to the light that travels from the collimator to the telescope, right? From the collimator to the telescope. Actually this is what needs to be done. Like, you need to make this parallel, right? You do not have to level this horizontally, right? What's required is not leveling this horizontal. What's required is to level this parallel with the light rays that travel from the collimator to telescope. Therefore you cannot use a spirit level, because what is required is to level the prism table parallel to the light traveling from collimator to telescope, and that's what's required, not to the horizontal. All right. Okay, let us move on to the next part. Okay, so let us go for the C part. So when they are saying when the telescope is at the position T1, the spectrometer reading is 279 degrees 58 minutes, and when it is at T2, the reading is 38 degrees 2 minutes, right? So, and then also they are saying something to us for us to note, that is note that the telescope passes the zero. This is the most important word, right? Like if you couldn't figure this out, of course that is because you might have not understood this phrase, that is note that the telescope passes the zero of the main scale when it is moved from T1 to T2. Actually they are asking us to calculate the prism angle. So we know that this angle, we know according to the theory, this angle is twice the angle subtended between T1 and T2 is twice the prism angle, right? So if we can find this angle, that is equal to 2 times A. So actually this is what they say. So this is T1 position corresponding to 38 degrees and 2 minutes and 279.58. So when they were moving, they had come across this, they have crossed the zero mark, right? That is what they are stating. Zero mark was crossed. All right. So simply we need to find what this angle is. How would we find it? By adding this angle. This is given what? 38 degrees 2 minutes, and then to that we need to add this, right? Let us assume this is θ1, this is θ2. So actually twice the prism angle is equal to θ1 plus θ2, right? So here θ1 is what exactly? θ1 is quite simple, 38 degrees 2 minutes, right? This is 38 degrees 2 minutes. How do we find this? This is simply from 360 you need to subtract this part, right? From 360 we need to subtract this part. If we subtract this part, we are going to be given with this, right? So let us write it out. From θ2 is from 360 degrees we need to subtract 279 degrees 279 degrees 8 minutes or something, right? So this is 58, right? So not 8, 58. All right, 58. So if you simplify, of course you are going to be given with, okay, 2a is equal to 118 degrees 4 minutes, which means a is going to be 56, right? No, 59 degrees 2 minutes, right? So this would be the answer for A, guys, right? So right, hopefully that is 59 degrees 2 minutes. This is the value for A. All right guys, so let us see the D part, right? Sorry. So in the D part, of course, what they are saying is to determine the angle of deviation of a light ray by the given glass prism, a student measured the incident and emergent angles, right? So they measured this is the incident angle and the emergent angle, I1 and I2 respectively, as shown in the figure. The graph shows I2 against I1. Okay, I2 against I1 is shown. So they are asking write down an expression for the angle of deviation in terms of the prism angle A, I1 and I2. Actually, this is where the initial this was planning to go, right? And now currently it is going in this direction, right? So actually this is the angle of deviation. What is this? Actually, if this is R1 and if this is R2, this is I1 minus R1. What's this? This is I2 minus R2, right? So simply, if you consider this triangle, D is equal to I1 minus R1 plus I2 minus R2. D is equal to I1 minus R1 plus I2 minus R2 is equal to I1 plus I2 minus R1 plus R2. What is R1 plus R2 now? If you complete this triangle, this A is this, since it is a cyclic quadrilateral. If this is A, this is also A. The external angle of this triangle is also A. R1, R2. So A is equal to what? A is equal to R1 plus R2, which means, so now finally we can write D is equal to I1 plus I2 minus A. Instead of R1 plus R2, we can write it as A. Okay, and then they are next saying determine the minimum angle of deviation D by using the graph. You need to understand when will you obtain what is the condition that the light ray would satisfy when it undergoes a minimum angle of deviation. It's pretty obvious that I1 is equal to I2. When the incident angle is equal to the emergent angle, then only a minimum angle of deviation would be obtained. How would you get the I1 is equal to I2 position? Draw a line. Simply draw a line, guys, right? Draw a line. All right. Okay, in this way, right? So see what is the angle it forms here, right? See what's the angle it forms somewhere here, right? So it's going to be something around 47.5, right? 47 degrees point 5 minutes, right? 47.5. Why did I draw a line in this way? Here only, this is a 45 degree line, right? 45 degree line, whereas I1 is equal to I2. I1 will be equal to I2 when along this line. So where this line intersects, this is going to be I1 is equal to I2 line, right? I1 is equal to I2 line. So therefore I'm gonna get that value, right? So in both these points you're going to get the same. It doesn't matter where you extend it and obtain, both the places you're going to get the same 47 degrees 5 minutes, right? So the minimum angle of deviation is 47 degrees 5 minutes approximately, right? Then they are asking next for us to calculate the refractive index of the glass prism is made out of, right? The refractive index. Okay, refractive index can be found, n is equal to sine A plus D over 2 over sine A over 2. we have all these values. Sine, what is a, what's the prism angle? We obtained it to be as 59 degrees 2 minutes, right? Plus what is d? D is simply sorry, right, this is not d, right? Sorry, all right, sorry guys, this is not d. Okay, so I made a mistake. That is, like, what is this? This is I value. This is where I1 is equal to I2. What is that value? 47 degrees 5 minutes. So if you need to find the minimum angle of deviation, we will have to go through, okay, I1 is equal to I2, which means 2I minus A. 2 times I is 47 degrees 5 minutes minus A. A is what? A is something around 50, okay, this is right, 59 degrees 2 minutes. This is going to be 35. If you simplify, it's going to be 35 degrees 58 minutes, right? Okay, sorry, okay, so this is the answer, guys. So n is equal to sine A, like when they ask us to find the refractive index, n is equal to sine A plus d over 2 sine A over 2. D is what here? 35 degrees 58 minutes, A plus d over 2, and then sine, what is A? 59 degrees 2 minutes over 2. You need to simplify. If you simplify, you're gonna get something closer to 1.49. Actually, actually this would be the end of the problem, guys. But if you see, when you compare this question with the previous year's spectrometer problem, this is somewhat, quite complicating because of the calculations that they have given in the latter part, right? So actually you will have to use some of the time, right? So like actually it will be time consuming somewhat when you compare with the previous years, right? So that of course is there, right? So other than that, of course, like all the stuff are quite theory, right? So they have asked the theory, but in this case, of course, like you need to know how to get the I1 is equal to I2 is equal to I incident angle, right? So that incident angle minimum, the incident angle corresponding to the minimum deviation point, that is, of course, you need to know how to get it, and then thereafter it's pretty much the same thing. I mean, like, you have to simplify it carefully, right? Okay guys, thank you, and see you on the discussion of, like, make sure to cover the essay discussion as well. I will be providing the link in the description below. Thank you, see you guys.